Hello, my name is Eliza. Thank you so much for listening to my project today. The title of my project is Identifying and Exploring Methods of Extracting Oxygen from Lunar Regolith. Everyone at one point in their life has imagined going to the moon, and I have always wanted to be a NASA scientist. And I want to get people to those dreams by eventually helping to colonize the moon. And to colonize the moon, we would need to break down some boundaries that arise when traveling there, such as not having enough water or oxygen to survive, or not having enough rocket fuel, also known as hydrogen, to get back to Earth. And what if the solution to all three of these problems was sitting right on the lunar surface? So that leads me to the general purpose of my project, and that is to see if oxygen can be extracted from the oxides in lunar regolith. The reason why I thought this would happen, and leads me to my hypothesis saying yes, this would be possible, is because when heat is added to a system, the energy from the heat vibrates the molecules, releasing the or breaking the bonds of the molecules and releasing the different atoms. So I did this by a few different methods, and I won't go into the detail of all of them, but it's basically one of the methods I did decomposition of the molecules due to pure heat, such as silicon dioxide, which is the main oxide in lunar regolith, which lunar regolith is made up of all oxides, and I did the decomposition of that due to pure heat and measured the oxygen just by monitoring the pressure versus temperature every 1 minute when it was heating up, and I heated it to 1262 degrees. The second part of my project was I heated a sample to 900 degrees Celsius and added hydrogen. And the reason I added hydrogen was to pull the oxygen out of the iron oxide. When iron oxide combines with hydrogen, it creates water. And water can be split fairly easily, and that leads me into the last part of my project, which was water electrolysis. And I did this and saw the effects of light on water electrolysis. So my hypothesis for this was basically that all these methods would be possible, and the method of adding more heat would be more effective and oxygen and releasing oxygen. And I accepted all my hypotheses, and these are just some graphs that show the different oxygen extraction and the pressure. There was a 0.70% decrease in the weight in procedure 1, which was heating it to 900 degrees Celsius and adding hydrogen. And in the second procedure of heating it to a higher temperature and not adding hydrogen, there was a 1.14% decrease in the total sample weight. So the importance of this is that when traveling to the moon, we wouldn't have to bring up a tons of oxygen or tons of water, because water is produced in one of these procedures also. So there was one last thing that I mentioned at the beginning of my project, and that was that not having enough rocket fuel or hydrogen to get back to Earth was also a challenge, and this could be solved by the following. So it is made of hydrogen, rocket fuel is, and hydrogen is the main ingredient of hydrogen. The hydrogen could be used to circle through the reaction with the iron oxide and combining the hydrogen with the oxygen in the iron oxide, and also the oxygen that has been released into the chamber due to pure heat. And then after the water is split through electrolysis, the hydrogen could be reused again as hydrogen or rocket fuel to get back to Earth. Thank you so much for listening to my project, and I really appreciate it. Winning the science fair would mean everything to me, and I really appreciate the time you spent in listening to my presentation. Thank you.